Okay, this will be the second part of our orthographic projection. So let's try to consider another example. Okay, so this time we will be given a latitude on the southern hemisphere. Let's say 40 degrees south. And now, LHA. So, be it star, planet, or sun. Let's say 285. And then, declination, 30 degrees south. And then we will be required to find for number 1, altitude. Okay. So sometimes it is denoted as letter H. And then your azimuth. And then your true azimuth. And let's try to find for your zenith distance. So these are the given values. Latitude 40 degrees south, LHA 285 degrees, declination 30 degrees south. You are required to find altitude, azimuth, true azimuth, and zenith distance. So without further ado, let's make our center point. So as far as possible, try to be accurate. And then practice, because practice makes perfect. So now I will draw my celestial meridian now. So this is my celestial meridian. So this will be my north still. And then this will be my south direction. Now notice that your latitude now is 40 degrees south. Okay? So for the moment, I will reverse this one, so that I can name this one as zenith. And now this will be my nadir now. So opposite to what we have shown last time, the previous example, that is latitude latitude 30 degrees north or 20 degrees north. So my point here is now it is the southern hemisphere, or your south pole will be the elevated pole and your north pole will be the depressed pole. Okay, so after drawing my celestial meridian, my prime vertical circle, and my horizon, I am ready to plot my latitude. My latitude is 40 degrees. So from here south, I will make an angle of 40 degrees. 40 degrees is here. I will mark. Connect them. Okay, so this will be my south celestial pole now, and this will be my north celestial pole. Elevated pole, depressed pole. Next, after drawing my axis, I will make a 90 degrees to that line. Oh, sorry for that. Degrees. And this will be my QQ or my equinoctial. So this angle from South Pole to the South Celestial Pole is equal to the angle with the zenith and the equinoctial. Okay. Next, I am ready to plot my declination. My declination is 30 degrees south. So sorry for reverse orientation. Okay. So declination is from equinoctial going to the body. So it is named south. So I will plot the declination towards South Pole. If the declination is north, you plot the declination towards the North Celestial Pole. So in this case, it is south. Therefore, I will plot here towards the North Celestial Pole. 30 degrees, 10, 20, 30. Okay, I'll make a line there. So this angle will be my declination. And then I will draw a parallel of declination. Just like what we did on the previous example. Only thing is, from the previous example, I did not name this parallel of latitude as D. So if you have noticed from the previous example, I have not labeled this parallel of declination as DD. Now it's already there. Next, since we are given LHA here, we can compute for meridian angle. So how? So from the relationship between the LHA and declination, we already have said that if your LHA is more than 180 degrees, your meridian angle will be 360 minus your LHA. So 360 minus 285 will be, meridian angle will be, subtracting them, 285, sorry. So this is 10, 5. This is 5. This will be on 15, 3. This will become 1. Okay, 75 degrees. Okay, so our meridian angle is 75 degrees. So after plotting my parallel of declination, I will make a semicircle. Okay, and then I will plot my meridian angle, which is 75 degrees. So now, consider your North Celestial Pole. So here is the North Celestial Pole. So everything in the west will be, everything in the left will be west meridian angle, and everything in the right side of the North Celestial Pole will be east meridian angle. So therefore, east will be plotted somewhere here. Okay, so from this center we'll make 75 degrees. Okay, 75 somewhere here. Okay, this is my meridian angle. Okay, so I will project this one. I will bring this point to the parallel of declination. So somewhere in this parallel of declination is the location of your celestial body. Okay, I will do that using this line. Okay. So this will be the location of your celestial body. So we have not specified if it is a planet or a star. So from this, we will draw the parallels of altitude. So from your horizon, draw a parallel line passing through the the position of your celestial body. And then we will name this as HH, or your altitude. Okay? And then you will measure this angle from your horizon to your parallel of altitude, and that will give you your altitude. Okay. So just like what I have said last time, I can use this angle also since they are the same. Okay. So this will be my altitude now. Let's try to find out. So my altitude is 9 degrees. So altitude equals 9 degrees. Now, from this parallel of altitude, I will make a semicircle again so that I can project here my azimuth. Okay, that will be my semicircle for the parallel of altitude. Now I will project this point here on this semicircle so that I can get my azimuth or my true azimuth. Using your prime vertical circle, project here. Okay, so I will make a line from my parallel of altitude and the intersection of my prime vertical circle. So where is my north direction? It is here. So my true azimuth now will be from the north direction clockwise. It will be where's my so clockwise we will start from here going there. So this is, I know this is 180 plus 50 57. So 180 plus 57 7, this is 3, this is 2, 237 degrees. So my true azimuth now is 237 degrees. Okay? And then for getting your true azimuth, so let's consider again your quadrants. 237 will be somewhere here because it's 180. So 180 minus 37, it is 57. So somewhere here is 57. So this is west. Therefore, 57 west of south. So this will be your altitude now. Sorry, azimuth. 57 degrees west of south. Okay? Now, we are asked also to find for the zenith distance. So from the previous example, we have said that polar distance is equals to declination plus polar distance and declination equals 90 degrees. Okay, so this will be 90 degrees minus declination. Okay, now for zenith distance, so since this is the altitude, the zenith distance will be from this angle going to the zenith. Therefore, your zenith distance plus altitude equals 90 degrees. Okay, so transposing it, zenith distance transpose this altitude will be 90 degrees minus altitude. Okay, therefore 90 degrees minus your altitude, which is 9 degrees, it will give you 81 degrees. So this will be your zenith distance. Okay, we have already acquired zenith distance, azimuth, true azimuth, and your altitude. Okay, if you are asked to find for the longitude, use this information and draw a time diagram. Okay, so that's it.